Hey, I wanted to show you this cool proof that the area of a regular dodecagon, a polygon with 12 sides of radius r, is exactly 3r squared. So let me show you how the proof goes. I'm going to start with a hexagon of radius r, and I'm going to complete it to a dodecagon. So I'm going to draw on top of it a dodecagon, still radius r, and I'm going to divide it in three equal parts. So this part, this chunk, and this chunk of the dodecagon are exactly equal because you can see there's four of these triangles in each one. So these are three equal parts of the dodecagon. So the claim to prove that the entire area of the dodecagon is 3r squared, I'm going to prove that the side or the area in yellow has area r squared. Let me move the dodecagon here to the side, and I'm going to prove that this area in yellow is r squared. And I'm going to break down that area, partition it into these other triangles, two in blue, two in purple, and two in pink. And let me show you now how I'm going to rearrange those into some other shape, a square. So let's start with the blue ones. The blue ones I'm going to put in this shape. And I'm going to show you, first of all, that these are indeed 90-degree angles. And that comes from the fact that in the previous images, so you can see that this line or this radius bisected this side. So over here, we have that these are 90-degree angles. So over here also I have that this is a 90-degree angle. So these are indeed 90-degree angles, and similarly that is 90 and 90. Now, what is the angle here and the angle there? This angle over here is 360 divided by 12. So that would be 30. So these angles here are 30s, and since that is 90, these are 60s over here. We will use that in a second. Now I'm going to bring the purple triangles over. I'm going to bring this one over here and flip it. So this side here, which is the radius, this side that has length radius, comes over here. By the way, I also wanted to show you that this length over here, what is that length? That length over here corresponds to this length over here, that if we go back to sort of like a picture with the hexagon has equilateral triangles. So this length from here to here, that is also r, or if you want, I'm going to draw it here, that is also r over there. So that means that from here to here, that is r, and that means that this is r. Now, as I've moved my purple triangles over, what I've said is that this side, which is also r, is the one that is over here. So this is side r, and this is also side r. What are the angles? Let me check. I want to check that this is actually a 90-degree angle. Remember that this was 60, but this angle over here, this angle right here, is one of the ones that we said is 360 divided by 12. So this is a 30-degree angle. So this is a 30-degree angle. And overall in here, I get a 90-degree angle. So this is 90. These were 90 and 90. So this is 180. So this is flat. And here I have another 90-degree. And remember that this was also R. Now let's put the pink triangles on top. So we are going to bring these triangles, the pink triangles, right over here. So let me see how they fit. They fit just like that. And let's check some of the angles here now. So we had that this angle was 60. This angle was 30. What are these angles over here in the purple triangles? Remember that this was over here. This is 30. But this angle over here in a dodecagon is 150. So therefore, one of them is 75 and the other one is 75 as well. So this is 75 and 75. What about the little pink triangles? This is 90 over here. This one over there is half of one of those. So this one is 75. So this little one has to be 15. So here I have 15, and this is 75, and those are a right triangle, a right angle over here. So this one is 75 plus 15, so it is also a right angle. And by the way, this side from here to here is again a side of the hexagon, of the original hexagon, so that is also side R. So this is of length R, length R, length R, and we have right angles all around. So this is a square of side R. Therefore, this rectangle over here has side R squared, and therefore the entire dodecagon has area 3R squared, which is what we wanted to prove.